Hola, buenos días. Gracias, Romy. Sí, me llamo Sam. Estoy emocionado porque estoy aquí con ustedes. Mi presentación, la promesa de la votación blockchain. Pero lo siento, porque mi español no es bueno. So I need to speak in English. So that's your first rug pull of the day. Apologies. I'll try to slowly go through this. But yeah, want to talk today about just the potential of blockchain voting, which is something very near and dear to my heart. So it's kind of a question, right? What is the promise? If you have read up or Googled around on this topic, you may have seen a wide variety of opinions, examples of city and national governments, states experimenting with early pilots of blockchain voting, and there's definitely excitement and eager participants to try all this stuff out. Here's one example, even in as early as 2018, so 6 years ago, right? Governments in Thailand, Russia, Japan, United States, all over the world, experimenting with early ways of how could we potentially run elections even on a blockchain. Meanwhile, you also probably hear of, reporters, researchers saying blockchain would be a disaster to run elections on, right? And, research papers from very prestigious universities and scientific clubs saying internet voting, blockchain voting, not a good idea. So what I'm hoping to do today is to kind of talk through some of the reasons why some people think it's really great, why some people think it's a bad idea, and hopefully give some clarity on how to think about it, and hopefully you can come up with your own conclusions by the end. So like Romy said, my name is Sam. I work at the Ethereum Foundation. Here's our Discord if you want to come say hi or have questions at the end. Let's get into it. So today, I want to talk about blockchain voting, some of the why voting, why is it important, what's needed in a voting process, what security and trust guarantees are super important for voting, what are some of the challenges, what are some of the opportunities, and where are we now with this technology, right? It's very early. Where are we now? Where do we think we can go in the future? So before I get into voting, I guess starting big picture of what is the potential of crypto broadly, right? Is it to improve money and finance? And I think, the creation of Bitcoin in 2008, I think was very much aimed at that, right? How can we add transparency and immutability and all these sound properties to money and finance, right? And that's awesome. That's a huge ambitious goal in itself. But I think a question a lot of us in the Ethereum space ask, right, is can we also build something even bigger? Whether that's, a better internet, a lot of talk about Web3, right? Building a better internet. Can we build a better world? Can we make a world that's more trustworthy, more democratic, more inclusive and transparent? A lot of these words you probably see and hear about this space. And that's why I think voting is a great example of that, right? It's not a specifically financial application. Sure, there might be lots of money on the line, but I think it's a good use case for blockchains that's not specifically financial of nature. And also, voting is important, right? Even if you talk about, elections, this year seeming to be a big one for that. Raise your hand if you've ever participated in a local or national election. It's something a lot of us go through as just citizens of the world, right? We want this to be a valuable process and a way for us to give voice and and empower us to help make decisions in the world. But what's the problem with voting today? I mean, ultimately, voting, I'd say, is just hard, right? You know, it's a fairly simple process when you think about it. But when you get into the details and see a lot of just resources go into it, again, taking elections as an example, very expensive to just ensure the security of the process, you know, the accountability of it, making sure everything runs smoothly. It's something, you know, governments and corporations spend a lot of money on to try to make sure that these processes are trusted. And yeah, again, there's, you know, laws, there's processes, there's a lot of things that, say, governments will do to try to ensure that these things go well. And in most cases, we could say elections work well. Hopefully, what most of us experience at the ballot box, right, is not this, right? Like, hopefully we have a safe space where, you know, there's privacy, we are confident that our vote is counted, we, you know, are able to access the polls and participate in this system. But even with that, you know, I'm from the United States. There's still issues in this supposedly, you know, advanced economy and advanced civilization that, like, people have trouble, like, trusting the system and believing that, like, hey, was this vote actually processed correctly? So I think a helpful framing to, like, try to compare different options here is just thinking through, like, what does a voting process need to begin with? You know, voting, it's critical to have process integrity. It's critical for things to be secure and trusted. So some of the dimensions I want to lay out here for how we, like, at the foundation have thought about it, is on a few different dimensions of, like, what does a voting process really need? And one is just correct execution. So what is that? Ultimately, it's pretty straightforward, that the result should be correct, right? That each single vote should be counted. The ultimate tally should be correct. And not only should it be correct, but ideally, it's guaranteed to be correct so that people trust that the results are correct, that people buy in and are convinced, hey, this process works. I know my vote was counted. I know my vote wasn't double counted. We want things to be correct, right? So that's one. Second one, I think censorship resistance. And that may be a term you hear a lot of in the blockchain space. But in short, anyone who can vote should be able to vote, right? No one should be able to prevent you from voting. And once you do vote, no one should be able to delete your vote, right? Your vote shouldn't be removed from the database by some system administrator. We want to ensure that, yeah, like, anyone who can vote can participate. And if they participate, their results are counted. Third, privacy is a really big area in voting. No one should be able to know who you voted for, or even if you voted at all, right? That's really important because we want each of you to vote based on how you feel, right? Not on how your neighbor feels, or some gang feels, or the police feel. You shouldn't feel like you're being judged for your own decisions. And, like, in an electoral process, privacy we view as super important. And finally, we think about collusion resistance. And what that really means is you should not be able to prove to someone else how you voted. So even if your vote was private and you were able to cast it, you should not be able to have a receipt to show to someone else how you voted. And why is that important? Well, bribery, for one, or just overall coercion. If someone's forcing you to vote a certain way, if you're unable to prove how you voted, it makes someone much less willing to pay you to vote a certain way. So selling votes becomes much less of an issue if you can't prove how you vote. So again, those are kind of the 4 dimensions we think about of like, what does a voting process absolutely need to be secure? And we can make a little table about this. So going back to, you know, the way things largely work across the world is in-person voting. And they try as hard as they can, but for this, I give kind of the shrug emoji of like, we don't really know for sure that, you know, the governments are correctly counting all the votes, that they're not censoring any of the votes. You know, I may think I have privacy when I go to the ballot box because I'm in a nice little cubicle and no one can see what I'm inputting, but I don't really know if they show my vote to someone else. And it's just a little unknown how things work today. Obviously, again, governments, corporations try very much to ensure to the degree they can, but there's largely no guarantees around how these processes work. So enter electronic voting, right? And like, why even bother? This, I think, is fairly simple. Like, we're all here at an Ethereum event. I think we all believe in technology largely, like the ability to use the internet for different processes would be much more efficient. So we could do it much more often, right? If you think about right now, most democratic votes, we give like 1 input every 1 to 6 years. That's not very frequent for, you know, democratic participation. So if we could vote more often on more things at, you know, smaller scale events more relevant to us, that would be a big unlock and a big opportunity for us in society. You know, if voting was as easy to use as Tinder, or you could just, you know, swipe on a candidate and say, yeah, I like them. No, I don't like that proposal. You know, is it as easy as a Twitter poll? I think we all agree like that would be better than having to take time off work, go to the polling station. It's just a very slow, clunky process right now. But one question is, without a blockchain, can electronic voting work? So people have been thinking about this question for a long time, way before blockchains, I'd say over 20 years. And the good news is there are some solutions for electronic voting or e-voting. I'd say the bad news is they all eventually make some trust assumptions of how things could and should work. And most of them kind of follow a similar set of techniques, which involve encrypting votes, setting up a system of talliers to count the votes. And this requires an assumption that the majority of these talliers are honest. And if you see a lot of these papers in recent years, they all tend to rely on this concept of a bulletin board to complete their security guarantees. And what is this bulletin board? They typically describe it as like this append-only database, if you will, where anyone can send a message to, anyone else can read from it, and anyone can ensure if they send a message, it'll get accepted. And maybe you can see where I might be going with this is like, it turns out blockchains are a great bulletin board, and they're already out live in public, and they've demonstrated their ability to be very secure in this specific use case. So why blockchain voting? I kind of already touched on it. But blockchains as a technology focus very specifically about providing guarantees around process integrity, right? If a process runs on a blockchain, or say a program running on Ethereum, that process is guaranteed to run as it's written. So these pre-agreed upon code and logic will receive inputs and calculate that consistent output, which we can see is very compelling to this type of use case. No one can prevent the execution from happening. No one can tamper or manipulate with the results, with the execution. And no one can block anyone else's input into the blockchain. So you can start to see some of these security guarantees we would want from a voting process. A blockchain solves pretty well. This is a screenshot at the Solidity documentation, which is one of the main programming languages of Ethereum. And you can see one of the first examples is a voting contract. This is a very simple example of it, and it's okay if you don't code. But I think the point is, like, it's pretty simple. You can see there's a vote function. It checks if the vote has already been cast by an individual. If not, it blocks it. And anyone can see and inspect this open source code, make sure it runs the way you would expect it to, and that the results are calculated. So in that sense, it's completely auditable. It's completely transparent to everyone to scrutinize the system. So we're done. We did it. Yeah, we did it. But wait, they're actually not quite. So there are some challenges. I mean, for one, I think there's the same challenges that any blockchain application faces. So if we were to do voting on the blockchain, we still have a lot of the same questions of just because it's on a blockchain, a software project can still be poorly implemented. Just because your shitty project is now on a blockchain doesn't mean it works well. So we still got to think about software quality. There's still UX concerns of just like, how do you manage your keys? There's scalability. There's acquiring Ethereum for gas cost. And there's one key aspect specific to voting, which is transparency, that ends up being a little bit of a challenge. So Ethereum, as you may know, like most blockchains, it's by default completely transparent. And this adds a lot of nice properties that other folks have talked about of it's auditable, it's open, anyone can inspect and scrutinize it. So all transaction data is public by default. But as we talked about with voting, privacy is actually really important, right? Like if everyone can see exactly who I voted for on the blockchain, that's not going to defend us against collusion resistance, right? Bribery becomes very easy. If I can just say, hey, check out my Etherscan transaction. It shows I voted for you. Now please pay me. So this is a serious problem with blockchains. So if we compare the in-person approach, Ethereum, like we just talked about, really good at correct execution, great at censorship resistance, but oh no, privacy, and as a result, collusion resistance is a bit of a problem. So I don't have enough time to like dig deep into the details, but the short answer is that instead of just abandoning blockchains for this reason, like a lot of researchers and news articles have of just like, okay, blockchains don't have privacy, let's just abandon them. We can actually solve some of these problems by layering on additional techniques on top of the blockchain applications. And in short, the answer is cryptography. Specifically, a concept called zero-knowledge proofs, which I saw there's a talk about later today, so check it out. But using ZK proofs, we can actually get all these different guarantees so that we can have privacy while having on-chain votes. And that's a really exciting future that is just becoming kind of production ready. There's a great recent post on kind of just like the state of different projects in Ethereum building private voting. Here's a quick overview of some. I'll talk briefly on the project I'm working on, Macy. You can see different projects have different trade-offs. But Macy specifically, I'll I don't think I have enough time to go through this. Basically solves this privacy problem by encrypting votes so that on-chain voting is still happening, but votes are encrypted and they're private. So any onlooker is unable to see how the votes are cast. But it gives some unique properties where a person can then take these votes, decrypt them, tally them off-chain, so by doing a separate process off of the blockchain, and then submitting the final results back on-chain. And that gives us a unique advantage where we still have everything on-chain that needs to be on-chain. So people are guaranteed to be able to cast their votes if they're eligible. They're guaranteed to just have those nice properties that blockchains give. But it also gives us some really nice privacy features to make sure that, like, hey, we can't prove how we voted, we can't bribe each other, we can't have all these issues that come up with these challenges. So in short, zero knowledge proofs, encryption, blockchain, by combining these different things together, we can actually come up with some pretty incredible solutions to build out on-chain voting. Again, I'm sorry, I don't think I have time to go through this stuff. I guess just to show where we are at now is, like, there's been research for a few years on this. We have open source code, and we have projects running some of these voting systems in production. This example is a project called ClearFund that has integrated this Macy privacy voting stack and is basically running like crowdfunding campaigns, which is voting with dollars, in production today. So the approach we're kind of taking is starting small and iterating. We want to become, the most secure electronic voting system in the world. We think Ethereum has the potential to provide this to the world. We're starting with Ethereum applications and Ethereum infrastructure. But what we're really excited about and moving towards is, like working with city governments, working with national governments to potentially run pilots of voting processes on chain. And if you know anyone who works at a local government, please get me in touch. So quick credits, Vitalik, who founded Ethereum, wrote this great post that covers a lot of what I did today. If you do want to check it out, there's a QR code right there. I was also able to work with someone, shout out to Chris Garner, who got this translated into Spanish. You can see the post was merged. I don't think it's yet been deployed. So this link might not work yet, but it will within a couple days. So if you want to be able to read about this in Spanish, encourage you to check it out very soon. I don't think I have time for questions, but feel free to hit me up and join our Discord if you do have questions. Thank you very much, guys.